Okay, we meet again. This time we're going to want to look at, we've done, okay, we're busy with binary arithmetic. We've done the addition, we've looked at the subtraction. Though we are going to come back to subtraction because we're going to start talking complements and how we can do the same, we can achieve the same subtraction, but we're using complements. But before then, we want to complete the four operations of addition, subtraction, multiplication, and division as basically as they come. Now we are saying we are busy with, okay, need a pen. We are busy with binary and the aspect of binary, which is the arithmetic, which is the arithmetic. Now, as a reminder, I said I will keep reminding people of this, and this is what the number of combinations is equal to 2 to the power of n, where n is the number of bits being dealt with, number of bits. So now, since we are doing the basics, we are going to look at 2-bit. I will say 2-bit. Okay. All right, binary arithmetic. So we're going to be looking at what combinations of what? 4 combinations. 2 to the power of 2 is what? Is 4. Therefore, we're going to look at 4 combinations, which is the count 0, 1, 2, and 3. There is our 4 combinations. 0, 1. Remember, this is the decimal count. Our binary count will be, for 0, we have 0, 0. We then have 0, 1. For 2, 1, 0, and for 3, 1, 1. 0, 1, 2, and 3. So this here, we are going to what? We are going to multiply. So this is 0 times 0, 0 times 1, 1 times 0, and 1 times 1. Well, we know here that the product is 0. As long as you are multiplying with a 0, your product will be another 0. Now, only when you've got 1s, 1 times 1 is what? Is 1. Now, if we look at examples, I'm going to look at, this is actually a revision in addition more than anything, because binary multiplication, any multiplication is actually what? Adding so many times. So if we say we look at our one example, we say, okay, let's start with an example right here. Let's say let's multiply the number 5. By now you should know why we're saying this is 5, and not multiplying that by what? By 7. And you say, okay, every time we have a 1, we just repeat the what? The multiplication. Remember, this is the multiplicand, and this is the what? This is the multiplier. So we then have, every time we have a 1 on the multiplier, starting from that position, we just write the multiplicand as it is. So from this position, this is the what? The LSD, we have a 1, so we just write out our multiplicand. Okay, we come to the second one. We say, okay, we have what? A 1 again. What do? We repeat. Let me make this a little bit longer. Okay, but I don't know, I will do that. I will do that in the coming examples, because I'm worried about space here. I'm worried about the space here. I'm in the way. So if I make it too long, I'll need to cut down a lot more. So I'll do that in subsequent examples. So for now, let's just do what we have. It's a 1, so we repeat from that position. We repeat the multiplicand. I'd like to make this smaller. I'm seeing trouble. I'm foreseeing trouble here. I'm gonna make this smaller. Now we have another 1, so we repeat 1, 0, 1. I'm making it smaller because I'm worried about if I'm going to be able to get my sum here. Now I'm going to add this. So what are these here? I could have put placeholders here to say I'm not starting here, I'm starting there. I could put 2 placeholders here to say I'm not starting either here or there, I'm going to start there. So these are 2 placeholders. This here is the intermediate products, so we call this the what? the partial product. So, and that there will be our final product. Our final product is our answer. Final product is our answer. Could have just called it the product. I'm just worried that there's product there. So I say I'll say this is the final product. All you have to do is add together the partial products, and you can see. That's why I say it's more of a revision of what? Of addition. That is a 1. Our base is 2. So that there is also a 1. 1 plus 1 is 2. That's 1, 0. 1 plus 1 is 3. 1, 1. 1 plus 1 is, what did I say there? I made a mistake. I'm saying 1 plus 1 is 3, and obviously that's not true. 1 plus 1 is 2. 1, 0. 1 plus 1 is another 2. 1, 0. So our answer there is what? 1, 3 zeros, 1, 1, base 2. Okay, if you look nicely there, we're actually multiplying what? 5 times 7, which should be 35. This is 0, 1, 2, 3, 4, 5 in terms of what? Of exponents. So this is 2 to the power of 5, which is 32. 32 plus 2 plus 1, and of course that answer is 35. So we've done nothing wrong there. We are actually correct. Maybe it would have been nicer. Maybe it would have been nicer to actually move the whole lot a little bit up, and then if I do that now, I can say move this a little bit up. Okay, so maybe I would have written my answers much clearer there. So probably I would say Control Z. I forgot that I grouped them together, so I could say probably could I ungroup? Control Z. Okay, probably now I'll just have to think, it's telling out was I grouped them together. So I'm wasting time on something that is not really the business of the day. The business of the day was basically to what? To show us how we multiply. So probably I'll have to ungroup and select again. This is the part that I'm not comfortable with. And select again because I wanted to delete that part. And then probably write my answers nice and big here. 1. This is my final product. 1. Answer is a little 2. This is 2. That's 1, 0. 2, 1, 0, and then 2. And that there is our final product. Okay, this here is our final product. So I want to make my things nice and neat. I don't like squeezing up work so it ends up not looking professional. So now let's say we try another example. Let's say we went back to this example. Let's say that example had simply been what? Had been 1, but it was comma 0, 1. Same digits, say there was a comma there, and then you say that times what? 1, 1, comma 1, 1, comma 1. And let's say we're multiplying these two. You would multiply this as if there was no as if there was no comma at all. So we would have an answer the same. We would do the same partial products. We would have 1 here, 0, 1 for this part. We'll have a placeholder and have repeat 1, 0, 1. When you say 1, repeat. So we put 2 placeholders. We repeat 1, 0, 1. That is our multiplicand. So we repeat it every time with a 1 on the multiplier, and obviously our answer will still be the same as that. It will be 1 there. It will be 1 again there. It will be 2 here, which is 1, 0. 2 here, which is 1, 0, and then 2, which is 1, 0. All right. So then, so nothing will change from the way we would actually do the multiplication. The only thing that will change is when we are done, we'll then come and count the total number of decimal places in the field. So between the what? Between the multiplicand and the multiplier. So there's a total of 1, 2 by the what? By the multiplicand, and only 1 by the multiplier. So therefore there's a total of 3. We come to your answer and count the total number 1, 2, and 3, and our answer would be so. The multiplication is done as if there were no commas. But then when you come to what? When you come to the answer, that is exactly how we did things in what? In decimal. Let's, as a matter of fact, look at an example like 1,27. We multiply that by 0,3. Let's say in decimal we did that. This is just a reminder. We'll say 3 times that is 21. 21. Say 2 times 3 plus 2, that will be 8. We say 1 times 3, it's what? It's 3. Then we come and say, oh, there's 1, 2, 3 decimal places in total, 1, 2, 3 decimal places in total, and our answer would actually be 0,381. So we are not doing anything new in binary. We are doing exactly what we've always done with what? With the decimal. Right? You do your multiplication as if there were no commas, and then you come and count what? The total number of decimal places. Now, let me take another example. Let's say I said, let's do 1, 1, 0, comma 1, 1, 0, 1 base 2, and you say we multiply this with what? With 1, 0, 1, 0, 1 base 2. What we'll do is, when we have a 1, we just rewrite the what? The multiplier as it is. Oh, first of all, I didn't want to do that. I didn't want to have a comma. So what I'll do is I didn't want to have a comma. So what I want to do is I want to do the numbers just as they are. So every time we have a 1, we repeat the multiplicand. That will be 1, 0, 1, 1, 0, 1, 1. We have a 0. So what do? We put zeros the same, because this 0 times that 0, 0 times that 0, 0 times that. So we are obviously going to have as many zeros as the what? Multiplicand itself. Alright. So then now what do? We come, there's a 1 there, we come and say, okay, we repeat the multiplicand as it is. Okay, now it's a 0, we put zeros, the same number as the what? As the multiplicand. So we have got 7, so we put 7 zeros. There's 7 digits there, we put what? 2, 4, 6, 7. Now we come there, it's a what? It's a 1 on the multiplier, so we repeat the multiplicand as it is, and we have, so once we are at the final one, obviously we are done. What we then do is this is our multiplicand, this is our multiplier, this is our partial products, this is, when we add, we're going to have our final product. Well, it's not bad practice to have zeros there. I'm not doing it for a reason. I wasn't doing it for a reason. I'll come back and explain that reason. But for now, because some people may be used to putting zeros, I'm going to put the zeros. So this is a 1. When we add, our answer is going to be, obviously, in binary. This is a 1. These are all zeros. Now this is 1 plus 1. That's a 0. 1. That's a 1, 0. That's a 2. That's again 0, 1, which is actually 1, 0, which is a what? Another 2. This is 1, 2, 3. So this is 1, 1, which is 2 and what? And 1. That is another 3, 1, 1, another 3, 1, 1, another 3, 1, 1, a 2, 0, 1, which is actually 1, 0, another 2, 0, 1, which is actually 1, 0 again, and this is again the same thing. So this here would have been our answer. Okay, if we're required to then do the what? To then do the answer in what? In decimal, we'll have to say 1 times 2 to the power of 0 plus 0, 1, 2, 3, 4. 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, and we'll have to add 2 to the power of what? 8, 9, 10 to the power of 11. Then we'll add those together. I think converting right now is really below our scope. We've done that already. I think people should be good with that already. Let's suppose, however, that this was a number with 3 decimal places and that was a number with 4. What you then do is you come to your multiplication and say we have 3, our multiplier has 4 decimal places, so we have in total we have a 7. We've got a total count of decimal places is 7. So therefore what we'll then do, come to your answer and count 7. 1, 2, 3, 4, 5, 6, 7, and say our comma would give us 7 decimal places, which is basically a total of what? Of the number in the multiplicand and the number on the what? In the multiplier. This is basically a what? This is how multiplication is done in what? In binary. So you see how I did it without the what? Without the commas. Okay, so if there's no commas, then the answer will have no commas. We just do what? Get our partial products and then add and get our final product. Now, but however, if we have commas, we then count the total number of decimal places and we come to the what? We say there is 7 here, because it's 3 and 4. We come in total and count the total of 7 here, 2, 4, 6, 7, and we come and we place our what? We place our comma to give us those a total of those 7. I don't think that was difficult. The only thing that I would like to do, well, probably I would request at this point that the students go through again and see, make sure that they understand. And then, however, I would like to proceed and show how the computer actually does the what? How it's not necessary to put these placeholders here, because I'll show you how the computer actually does the actual what? Multiplication. Let's go and say, let me have a new page, a fresh page, and say, how does the computer actually do this? How the computer does how computer multiplies. Obviously computers do binary, so we don't even have to say it's in binary, because the computer only knows binary. Okay, that is the language of the computer. Okay, the different programs may then what? May then seem to use different languages from binary, but all of them are versions of binary. So how does the computer multiply? Let's take an example like 1 0 1 1 1 0 1. Just make it long so that everyone understands at the end. This here is going to be multiplied by 1 1 0 1 0 1, and then you say this is the multiplicand, this is our multiplicand, and this is our multiply. So this is multiplicand, and this is our multiplier. So all you do is load those in what? Load multiplier and multiplicand into the what? Into certain stores. All right, what you then do is the computer will then say, okay, we are going to multiply these two. So the moment you hit the multiply, the computer will run a program that says multiply. What does that program say? Load the first number into a certain store, the multiplicand, load the second one, the multiplier, into another store. Then it will say, every time that the program will say, every time that we see a 1 on the multiplier, we repeat the multiplicand. Okay, so let's say, all right, we see a 1 right now. What does it say? It says, okay, we've got a 1, so write the multiplicand. 0 1 1 1 0 1, and then what does it do? It's saying 1 on multiplier. What does it mean? Load multiplicand into some store, ne? Load multiplicand into some store. All right, so then what we have added that, what do we do? It says, okay, after you load, what do you do? It says shift 1 digit. I should have just used the one digit to the right. So this is the right shift register. We're going to use the right shift register. Shift 1 digit to right. What do you mean? This is where we end. I'm going to try to be as straight as I can, meaning I'll be a little bit slow. Okay. Then we say, okay, so what do we do? this number shifts one digit to the right. So this becomes the 1 comes this side, and then the 0 is here, the 1, the 1, the 1, the 0, and the 1. In case you don't understand what I'm doing, all I've done is shift each digit one digit to the right. Okay, so I've shifted every digit one digit to the right. Now we look at the multiplicand. Multiplicand says 0, so you add as many zeros as you have on the what? On the multiplicand. So you have as many zeros as you have digits on the multiplicand. So you have 7, 2, 4, 6, 7, 2, 4, 6, 7. So what have you done? You 0 on multiplier, load digits, load 0. Okay, what do I mean by load 0? You are loading as many zeros as you have on the what? On the multiplicand. So what do you do after you do that? You add. Let's number these steps. Let's say this was you loading the multiplicand, this was step 1. Let's call this you loading the multiplier step 2. Let's say using a 1 on the multiplier and loading the multiplicand was step 3. Let's say this was step 4 and you loading zeros was step 5. Now step 6, you then do what? Add the contents of 4 to the contents of 5. Okay, add contents of 4 to 5. So our sum here will be 1, that one there 0, that one there 1, that one there 1, 1 and 0 1, 0 and 0 0, 1 and 0 1, 0 and 0 0. So actually there's nothing here. So what have you done? After you add, what do? You check the next one. What do you see there? You see a 1 on the multiplier, so you load the multiplicand. 1. Where are we? We are here. Okay, we are here. We've seen a 0 and we've added a 0. Okay, after adding, we actually skipped a step here. After adding, we shift one digit. I should have said shift instead of 1. Let me rather use language that will make it easy for students. Let me say load step 3, shift the contents of 3 one digit. Shift the contents of 3 one digit to the right. Okay, after that I add 4 to 5 and then I shift the contents of what? This is 6. I shift the contents of 6 one digit. We are using a what? A right shift register. One digit to the right. Okay, then what do you do? So this 1 moves one digit. This 0 crosses the line. That 1 comes there. That 1 comes there. That 1 comes there. That 0 comes there. That 1 comes there. That 0 comes here. And this is our step 7. Okay, what we then do is we go to our multiplier. It says a 1 there. We repeat 1 0 1 1 1 0 1. These are what? This is 1 on multiplier. What does it mean? 1 on multiplier. What does it mean? Load multiplicand. Okay, what we then do is after loading, each time we load, we then what? We then add. This is step 8. We then add contents of 7 2 8. So this will be 1 0. This is 0 1 is 2. 1 plus 1 is 2, so it's 1 0. This is again another 2. This is 3 1 1. This is 2 1 0. This is 3 1 1. This is 1, and this is 1. After adding, what do? We shift. This is 9, so we're going to shift the contents of 9, always 1 digit to the right. Again, a reminder, what register we're using here? We're using the right shift register. So when you shift, this is going to go to a 1. That 0 will come there. That 0 will come there. That 0 will come there. That 1 will come there. That 0 will come there. That 1 will move 1 digit, move 1 digit, and we have what we call step 10. What you then do is, we will then say, okay, we are going to look at our what? After shifting, we look at the multiplier. We have what? We have a 1, so we load 1 on multiplier. I wish I could just copy 1 on multiplier. So what do? We load multiplicand. Okay, so what do? We load 1 0 3 ones, that's the multiplicand, 0 1. And then this is step 11. So what I'll do after every time we load the multiplicand, what do? We then add. We add that to be 1. What are we doing? We are adding 10 contents of 10 to contents of 11. So in 10 we're adding 10 1 0 1. No, what am I doing? 0. Okay, that's a 1, that's a 1, that's a 1, that's a 2 1 0, that's a 3, that's a 3 1 1, that's a 2 1 0, that's a 2 1 0. Now what we then do, we then say after adding, we shift. That one comes here, that one comes there, that one comes there, the 1 comes across, the 1 follows, that 1 follows, that 0 follows, that 1 follows, that 0 is following, that 0 follows, and that 1 follows. So what we have, this was step 12, this is step 13. After adding, every time we add, we shift this is 12 1 digit to the right. Okay, so after shifting, we look at the multiplier. All right, we've seen 1 on the multiplier is what we started with, 0 on the multiplier was next, 1 on the multiplier. I may have made a mistake here. 1 on the multiplier. The next one was a 0 on the multiplier. I think we looked at the wrong number. We probably looked at step 3. This one, it was 1 0 1. This was supposed to be a 0 1 0 1. This was supposed to be a 0. So no use to panic. We just correct that. That's a 0. Therefore, we load 0. Okay, we load 0. When we load 0, we are actually loading what? As many zeros as what? As the multiplicand. So we actually load 0 here, not multiplicand. I meant to use a rubber. So this was load 0, 1, 2, 3, 4, 5, 6, 7. Okay, so then we're supposed to add 10 and 11. When you add 10 and 11, we wouldn't have got that. We wouldn't have got this. We had the wrong one. We would in fact probably have the 1 here, the 0, the 0. What are we doing here? We are adding the 0, 1, 0, 1, and then 1, 1, 0. So 1, 0. I'll go through this just to double check later. If there's something correct, I'll probably correct it in a later video. So this here, after that, we shift. That 1 comes there, that 0 comes there, that 0 comes there. So it doesn't look like the rest of it is correct. So that's 0, 1, 0, 0, this 0, that 1, 0, 1, 1, 1, 0. Okay, so after shifting, we look at what? So we've done 1, 0, 1, 0. This was a 0 on multiplier. This was a 0 on the multiplier. So 0 on multiplier, it loads zeros. So now what do we do after shifting? We check 1. So we are here now. We say it's a 1. Need to be careful with this. 1 on multiplier. So what do? We load multiplicand. I hope it was multiplicanding. Now when we load the multiplicand, this is step 14. What's the multiplicand? It's a 1, 0, 1, 1, 1, 0, and 1. What do we do after loading? Each time we load, what do we follow with? We follow up with an add. What do we add? The contents of 13 to 14. Okay, what are these actually? These are actually your what? Your partial products. Okay, so we keep adding to our partial product. So what is happening is that each time we either load zeros, whatever, we have a partial product. Next step, when we load, we add to that partial product. So these are our partial products. So after loading this was our partial product. We shifted. After shifting, we put the zeros. That was our second partial product. After that, we shift, we load. This was our third partial product. So every time that we load, we follow by what? By adding and by adding. So these are what? This is the process that basically we're doing when we're doing what? When we're doing it on the, not like the computer is basically trying to assimilate what you've been doing I know it makes it a little bit more, it hides that it's actually doing what we've always been doing. Now if we look at after adding that one, we add, after adding that 13 to 14, we'll have 1, 0, 0, 0. This will be 2, which is 1, 0. This will be 1. This will be 2, which will be 1, 0. This will be 1, 2, 3, which is 1, 1, which is 3 again. 1, 1. This is 1, and this is 1, and this is step 15. Okay. Now, after adding, Okay, I should have probably brought this down. It's a little bit I don't like the way it's cramming up. I don't like the way it's cramming up. Probably put it down so that at least okay, so that at least, yeah. So I'm trying to line it up with the instruction there. Okay, I'm trying to line up with the instruction. Now what have we done? We've added. Every time after we add, what we do, we shift. So we are going to shift one space to the right. That's a 1. We're using what? A right shift. A 0 comes across, the 0 follows, that 0 follows, that 0 jumps the line, that 1 follows, that 0 follows, that 1 follows, that 1 follows, that 1 follows, that 1 follows. Okay, and then what we then do is we were shifting number 15, what? 1 digit to the right. Okay, I'm not happy. I'm not happy. I'm squeezing up too much. 1 digit to the right. Okay, now after we shift, what do? We check the multiplier. We've done 1, that 1. We're starting by the what? By the least significant digit. That 1, 1, that's 0, 0, that 1, 1, that 0, 0, that 1, 1. We only have 1 left. So it's the last time. What do? We see a 1 on the what? On multiplier. Could I possibly move this a little bit up? 1 on multiplier. 1, I see a 1 on multiplier. What do? Load again our multiplicand. So this is what the program will be doing. It will be telling you load multiplicand. Then now what do? We load the 1, 0, 3 ones, a 0 and a 1. Then now what do? This is step 16 there. We skip step 16, which was that. This is step 17. Okay, what we then do, we add. When we add, that's 1, 0, 0, 0, 0, 2, that's 1, 0, 1, 2, that's 1, 0, 3, that's 1, 1, 3, that's 1, 1, 1, that's 2, that's 1, 0, 2, 1, 0. So when we do that, we'll probably shift to 1 space to the right again, shift for the next, I don't have space now. I'll probably shift 1 space to the right, but already we have an answer here. Step 18 is already our answer. But if we're limited, if our left hand side of the line was limited to what? To certain number of bits, we'll have to shift 1 space to what? To actually accommodate that last bit there. Alright, so but ultimately that's an unnecessary step as far as our answer is concerned. That there is our answer. Right, so if you look, our answer is obviously going to be in base 2. Everything here is in what? Is in base 2. This is basically how our computer will do this. Let's see on the what? On the right hand side there, on the left hand side here. Let's see if I can what? I can actually say what is 1 humans. This is you, humans. This is what we would do. We would say it's always best, I know I'm going to be moving in the other direction, so it's best for me to say, what is 1? I'm going to try to make it small. 0, 1, 1, 1, 0, 1. We're proving our answer times 1, 1, 0, 1, 0, 1. That's 2. As a clever human, I'm cleverer than the computer. I'll probably worry about ones only. I'll say there's a 1 here, so 1. That will be okay. I'm multiplying, so I'm repeating the what? The multiplication there. 1, 0, 1, 2, 3, 0, 1. Then I'll come and say here it's a 1 again, so I'll repeat the multiplicand. 1, 1, 1, 0, 1. I have 2 more ones. 1 there. 1, 0, 1, 1, 1, 0, 1. Finally, I will say 1, 0, 1, 1, 1, 0, 1. And I'll put these partial products together. I'll say add them. That's a 1. That's a 0. Our answer is base 2. That's a 0. Carry 1. That's a 0. Carry 1. That's a 4. 1, 0, 0. That's a 2. 1, 0, 2, 4, 5. That's a what? 1, 0, 1. That's 2. 1, 2, 3, 4, 5. That's a 1, 0, 1. That's a 1. That's a 2, 1, 0. That's a what? A 2, 1, 0. And let's see if the two are the same. 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 0, 1, 0, 2, 4, 5 ones. That's it, 1, 0. That's it, 1, 0, 2, 4, 2, 4, and the 1. And as you can see, our computer has done a what? A marvelous job. So we get the same answers. So basically, I've shown you how to do the multiplication, which was a short session. What has turned out to be a longer with the little mistakes we made here and there. What has turned out to be a longer job has been what to demonstrate how the computer will actually do the job. As you can see, once this computer is doing, once we do the multiply, what did we do? What we didn't mention here as the final step is add what? 17 and 18. So basically, every time we multiplied, we got a partial product. Every time we multiplied and added, we got a partial product. Okay, so this is basically how the computer does the job. I hope you understood. If there's any questions, I'm only a contact away. Get in touch and I will revert to you. Thank you. Enjoy yourself. Bye. I hope I turned multiple cans into multiple candies. Ne? Enjoy yourself. Have a good day.